We have some of the PM team here. We'll do a quick round of introductions. Hi, I'm Steve Spiker. I work on the Dev Experience side and different cloud-hosted offerings.
Hey there, Rob Sumsky. I'm a former Choreo PM working on Tectonic and own some of the console and operator SDK.
Hi, I'm Tushar Katarki. I work on the OpenShift PM team and some of the day 2 stuff like monitoring and logging and metrics, etc.
Mike Barrett, guess what? I'm a PM. I look after the Kubernetes technologies.
And shockingly, my name is Mark Curry, also a PM, and I focus on container infrastructure, like networking and the masternode and scale and so forth.
Great, so let's get started. First off, we need to read this. Everyone, there's going to be some clipboard being passed around. Make sure everyone signs it. Just kidding. What this says is more or less everything we say to you may be a lie or may be truth, but no, I'm just kidding. It's no forward-looking statement. We try to lay out the roadmap for the next 12 months. Some things we'll say we'll make it into the product. Some things we, like sometimes, like if you look last year at a roadmap, we didn't have acquire core OS on our roadmap. That just sort of, that's part of it, happened. So that changes our plan a little bit. So good things like that. So what we're going to take you through is a day in the life of sort of people on the platform. Since we're PMs, we can't count right. So we're going to start with day 1, then go to day 2, and then day 0. We're going to look at an efficient tenant, someone using the platform, how they can be efficient on it. We're going to look through how we can empower operators on it, and then we're going to look at some platform efficiencies in day 0. And unfortunately, my laptop crashed right before I started, so I'm going to have to queue up a couple of my demos. So first off, as a developer comes into the platform, maybe looking at some great content and say, boy, I'd really like to deploy some new applications. And the cool thing about this is, you have control over the content. So like Go, I'm a developer. Go is a pretty cool thing. I want to get started with that. That's nice. Node.js, all kinds of things in here. What can I do? Let's just go ahead and get started with a new project. And this is a fun thing to do. We can put emojis in our project display names. So it is supported. That's our most important feature. Most requested, I'm sure. So Go's great. We have that coming. It's SCL and the DevTools are delivering Go-based builder. So we can define that. I'll speed it up a little bit for sake of the demo. And this is intended to show you that as a Node.js developer, if you could really look at that, I'll zoom in. Node.js 10 was just released from the community a couple weeks ago, and Red Hat OpenShift application runtimes is also coming out with an updated version of their Node.js piece with Node.js 10 support. So things that developers are looking for. So jumping ahead, as I'm in the container, I can also, you see, within the same experience, I'm able to work with many different technologies. It's real quick and easy. I leverage the platform as intended through containerized applications. So Java, Node.js, and Golang. Again, apologize, I have to queue these things up. A couple other technologies I just want to highlight real quick. If you want to get started quick, you can actually host a Roar, a launcher on your platform. So you can quickly get started with different application runtimes. And again, I'm talking about future statements here. And then also hosting Eclipse J on the platform itself. So if you want to have hosted workspaces and development environments. And lastly, I feel like I can't do a presentation without a pipeline demo. So we can take our Golang example, we can pipeline enable it. So without having to create a new pipeline or a new project, I just associate the pipeline with it, and then there it's actually able to build and get going pretty quickly. And lastly, well, not lastly, I have a couple other things I want to show. Is a command line interface. So if you want to streamline development, I'm a command line junkie. We have a command line heroes podcast, so everyone's about command line. So here we're going to show how we can quickly take a concept of a component. We can take that component. We can then create a backend with it. Oops. It builds that quickly after we do a ODO push. We can add storage to it. We can list out the storage. And then we can do a thing where you're able to, sorry, that's flashing too bad, where you can actually show, like you can do a rsync or a watch type and watch the changes as they occur. And then as we work with that type of application, we can have an application view in the console, which allows us to organize and look at our application based on the components. So the web UI, you can think of the console as now looking more application-centric, and you can look at how the different components are stitched together. You can possibly drill into them to see different aspects of the application. What's the drilling's not working? But that's basically what I wanted to show you as far as efficient tenant on the platform, being able to work with applications directly, new content as you would expect, quickly pipeline enable it, and then become efficient. And then I get to the point where I want to hand it off to sort of a day 2 operation, so I'll hand it off to Rob.
All right. So if you saw the keynote yesterday afternoon, we have an entirely new view coming to OpenShift, which is an admin-focused view to augment the existing developer-focused view. And so this is bringing in some cluster-wide views so you can cross-cut across the namespaces that if you're an infrastructure admin, you're managing for all of the engineering teams that are using your cluster. And this is things like monitoring via Prometheus, looking at events and crash looping pods, that type of thing, as well as proactively managing all the resource quotas, namespaces, and that type of stuff. And access control is another key feature that's coming. This is a view that you've been able to kind of have on the OC command line, but not have a web GUI for. And this is really nice for RBAC because, once again, it's all namespace based. And if you can drill in and go link the roles and the role bindings and see what namespaces they're in and have one list for it, it's really important for auditability. So if you're doing a security audit or you want to see exactly what access either a user has, you can do that all from the console. As well as generating new service accounts, mounting those secrets, seeing what they look like across the projects and namespaces that you're managing. And then on the administration side, bringing in the concept of our application operators. And I'm going to do a whole demo for what that means. And then another view that you've never had before is the just administration of nodes, being able to drain nodes, even see what nodes you have and their statuses, all their health checks, looking at if disks are full, that type of stuff, is all super important. And we're going to ship a set of default monitoring rules that are looking at all the common baseline things that you would want to know about nodes, as well as the health of the control plane, things that keep your cluster functioning. And then most exciting is bringing the concept of automated operations to OpenShift. This is a core tenet of the CoreOS Tectonic platform, and we're really excited to kind of re-platform OpenShift on that technology to power those in-place, no downtime rolling updates of the cluster itself. And so this helps you out not if you're just running one cluster, but we typically see folks that are running 5, 10, 15 clusters, either across different clouds, or different environments. If you want to have a point of presence in every Amazon region, for example, managing the upgrades of those clusters is pretty difficult, but you can do it with a one-click upgrade. So we're very excited to bring that to OpenShift. And also that we announced the open source operator framework, and this is what's going to power a lot of the automated operations in OpenShift for the components, but you can also model your own applications this way. And this is a concept that CoreOS introduced in 2016, and we've been building on it ever since. And we're really excited to bring this to the world, as well as from an open source perspective and then a commercial perspective that we announced at the keynote yesterday. And what's really cool about this is, stateful workloads have been traditionally pretty hard to run on Kubernetes because they need extra logic. There's logic around doing database rebalancing or backing up before an upgrade or pre-warming caches, whatever you need to do to make your app function. and you can put that all into software, and we call that an operator. And this concept has taken off, and you can see that there's a number of operators that exist for pretty complex things. MySQL, Couchbase, doing storage with Rook, etcd, Prometheus, Spark, all these things are stateful workloads that you can run in Kubernetes with an operator. And you can check out more on GitHub. We have an SDK for building operators, as well as a lifecycle manager for managing instances of those that are running in the namespaces across your cluster. This is what the general flow looks like for using the SDK. We have some code gen that will give you a foundation to work from, and then some tools to help you test locally on your laptop and when you're developing your operator, as well as testing against live clusters. This is going to work really well in OpenShift, but we want this to be a Kubernetes-wide practice, so you can test it against GKE clusters, Amazon clusters, that type of thing. And we want that to be across the board. And then once you're done and you want to publish a version of your operator, then you produce a manifest that gets given to your customer to run on their cluster, and then you have a container image that's hosted on something like Quay. On the lifecycle management side, if you're an admin and you want to consume one of these operators, you take that cluster manifest and you register it with the cluster catalog, and I'll give a demo of that in a second. And then users on your cluster are now free to instantiate that in their namespaces. So a really popular one that one of our customers, Ticketmaster, uses is the Prometheus operator to allow each application team to instantiate their own monitoring infrastructure, so they can decide how long those metrics are retained, exactly how it's scaled. And then because that's coming out of their quota, they're effectively paying for that. And so this is what the Lifecycle Manager lets you do, but for Spark and all the stateful workloads we just talked about, as well as modeling your custom app that way. And so what I want to give a demo of is the combined console that shows this Lifecycle Manager from the OpenShift side that you've traditionally used on the developer experience, and then as well as the new cluster admin console. And so let's take a look at that really quick. So let's start on the traditional experience that you get out of OpenShift today, looking at the cluster catalog. This is all the stuff that you already know and love in OpenShift. This is your Jenkins and MySQL and that type of stuff. I didn't log in. And what we've done here is use the service broker interface to expose our operators from the administration side of things into the cluster here. So you can see Couchbase, etcd, and I can filter this so you can see. These are the operators that we've exposed, and so if you're a user and you have access to run Prometheus, like in our Ticketmaster example, you can self-service consume those, instantiate as many as you want, and bind and get the secrets to use that service. And then from the administrator side, this is the brand new experience I was talking about. You can jump over and switch context into the cluster console, and this is optimized for an admin as well as an end user that wants to have more of a containers as a service type experience versus a developer focused experience. And we'll wait for this to load. And when this loads, what you'll see is our new Prometheus monitoring stack. And so right here, we're looking at the status of a namespace. So in this case, the default namespace. But there's also an all projects view. And this is that cross-cutting view I was talking about, where you can see some health of the cluster and crash looping pods firing alerts, as well as the control plane status, do some capacity planning, and then look at a cluster-wide event feed. This is surfacing really good information. Like here, there's this restart of this container is failing, so I could go possibly investigate that. Some other things that are in here, in addition to your just regular workloads, we've got all the Kubernetes objects in here. But the exciting part is this administration view, where you can now have access to do node operations, look at if I want to unschedule all the pods from this node, if I'm going to take it down for maintenance, just see what the health checks are looking like. This is all stuff that's never been done before in OpenShift. And then I spoke earlier about RBAC, and this is the role binding screen, and this really, I think, shows off the power of this screen. So you can filter by just look at namespaces and see who's bound to admin, for example. Here we have a number of namespaces, or you can look at just cluster-wide role bindings for folks that have elevated access across the cluster. And then as well, there's also, did you even know that there were 126 system role bindings? Kubernetes itself under the hood uses these for all kinds of things, and so you can look at those as well. The last thing I'll show, I think I'm a little over time, is that You get an integrated monitoring for the pods that are running on your cluster as well, and this is all powered by Prometheus, and this is a really great way to see if containers are running away with resources, and then you can look at customized event feeds if they're ready for this pod, for example, and stream logs, all that good stuff. This mirrors some of the functionality that's already in OpenShift today. And that is all I'm going to cover on the combined console. We're really excited to bring this to the platform and hopefully help all of y'all run not just one cluster, but 3, 4, 5 clusters, administer them really well. Thanks.
Thanks, Rob. Next, I'm going to talk to you about monitoring and observability. I think that it becomes a key part of any day 2. And OpenShift, as you think about setting up your CI/CD or DevOps pipeline, running applications on OpenShift, you also need to think about what your monitoring and observability pipeline, if you will, look like. And starting with metrics, you collect metrics, traces with tracing, then you have some alerts that you define based on that are important for you, and then you get the alerts, you define some kind of a healing rules, and hopefully you can automate them so that you can heal that, and then once the corrective action has been taken place, I mean, you want to automate that, you want to be able to root cause analysis with logging, and then you want to be able to collect metering information as well as do reports on this for more long-term trending. So all this, some of this already exists in OpenShift, as you already know, and some of this we are shipping with Prometheus Tech Preview, for example, and we're going to obviously add more features to it and make it GA, and some others are new, like tracing with Jaeger, and I think there's another demo coming up, and then metering is the next one, and all of this is going to be tied through together to the operator framework that Rob talked about earlier for all the goodness. So one of the exciting new things that I'm going to talk about, which is coming on OpenShift going forward, is metering. It's going to be based on Prometheus. It basically uses the Prometheus metrics to do reports based on namespaces, based on pods, based on label queries, and that means that you could say that for this namespace, for example, give me, you can generate a report for how much CPU was used or memory was used, et cetera, and you can ship that to an object storage, and then you can consume it either manually or maybe you can send it to your accounting or custom software for billing and other advanced capacity planning kind of stuff. So with that, what I wanted to really show you was an end-to-end demo of some of what we talked about a little earlier through, so what you'll see in this demo really is that you're going to see an OpenShift cluster running on Red Hat virtualization, and then you are going to define some alerts, and then you're going to define some heals. If that alert gets triggered, what do you want to do? And you'll see that this one happens to be about CPU utilization. If it actually, if the idle time goes beyond 80%, or less than 20%, then it'll trigger an alert, which will then result in some more CPU capacity being added via Ansible Tower. So you'll see that in just a moment. Yeah, so this is it. Give me a second. So as you can see here, this is a Red Hat virtualization console, and there you can see that there are is a 3-node cluster, and it is kind of at steady state. The CPU utilization is like 5–10%. Things are hunky-dory. You then basically you have defined a rule, which is what this shows, or a self-heal script, which is in Ansible. It's an Ansible playbook, which basically increases the number of CPUs available for that particular node. This is what this does. Then you go into Ansible Tower, and then you create a template for it, and you import it by pointing it to the GitHub repository. See, you have a template for increasing node CPUs here. And then once that happens, you go to your you define your alert rule. As you can see here, if the idle time becomes less than 20%, then you're going to fire this alert when we call it node CPU high. Here at steady state, things are going well. The utilization is pretty low. The idle time is high. And then what we're going to do next is we're going to trigger basically trigger a condition which basically pins the CPU to 100%, which is what that does, the DD there. And so following that, if you go back to the dashboard, the Prometheus dashboard, you'll see that the CPU actually has, the idle time has gone to 0. And therefore, what will happen is that this node CPU high will first go into pending, which you can control with that lever there, and then it'll basically then go active, which you can see on the Alert Manager dashboard. Following that, what will happen then is now you'll see that the service, which is running on OpenShift, will receive that alert, and then it'll basically call the evasive action that you want to do, which is to increase the number of CPUs, which is what it basically calls this job. The job gets executed, and then once the CPU, the number of CPU, which then calls Red Hat virtualization, and there you can see on the console that basically CPU got added, so the CPU utilization is back to like 50% now, and the alert has finally cleared as a result of that. So this kind of gives you an idea of how you would have an end-to-end workflow to take evasive action or in result to some error conditions. With that, I'll hand it over to Mike.
Thanks, Tushar.
There you go.
All right. How many people out there own more than one OpenShift cluster? All right. And how many people love updating that clusters? Come on, you love updating those clusters. Yeah. Well, we know it's an issue, and we want to solve that issue. And as Rob mentioned before, we have some really awesome technologies that we brought into the product from CoreOS. You know, I could use the word automate, but this is more than automation, right? Automation is typically when you have command lines and you're hitting existing procedures, and you're just not involving humans, you're removing that component. This is redefining how we install our product, how we deploy our framework, how we self-host those components, how we organize them through operators. This was a massive undertaking that we've done to alleviate this issue. And the result is you're going to have two paths moving forward. You're going to have an unbelievably awesome automated experience all the way down to the operating system. And please, I beg of you, take advantage of that when we give it to you, right? How difficult is it to patch your RHEL operating system on a different maintenance cycle than the rest of the platform, right? It's a difficult thing to find that many maintenance windows. If I define the platform today as from the operating system all the way up to the platform, and I help you with your infrastructure automation with a click of a button, and I self-host those components on Kubernetes, and I redefine the API that you hit to be a larger task, a larger action, we have a very high level of confidence that we're going to be successful with that upgrade. So please take advantage of that. We're not naive. We realize some of you have a RHEL build that you've probably built over the last 10 years, and maybe you can't let go of it just yet. So if you need to hold on to that RHEL a little bit longer, we have that solution as well. You can bring up the RHEL. You can give us an inventory file of IP addresses and how you log into it, and then we will take over the automation from there. So those are the two existing install paths that we will have towards the end of the year for you to solve this issue. The third one is pretty clever, and this one's under development, so I have some screens of it. But the concept here is, what if we installed Kubernetes and we let Kubernetes install our clusters for us? It seems to be doing a pretty good job with applications, right? I can explain in a pod spec how I want my application to look. It deploys it on the cluster. It constantly looks out on the cluster to see if it looks like the YAML. If it's not, it destroys it, recreates it again. If I change something, it fixes that for me. What if I could explain my cluster in a YAML file, and I could feed it to Kubernetes, and I could do that with 100, 1,000 clusters, right? Just like they were applications. That's the path that we're moving forward with as a way to solve having more than one cluster. So here, when you notice my screen, and you don't have to read this YAML, you should feel the YAML because this is all going to change, right? We have to write some of these APIs before the core OS bits are baked. So this is all in flight, but you'll get the concepts. When we look at this, I'm asking it for a definition of a version. I'm saying, hey, what versions do I have? And that means there's a definition of version for the first time for the entire cluster and all of its components, right? That's a huge step forward. The next part of this is I can tell it which images to use, right? And I can tell it which AMIs to use. And did I just say AMI? We're going to have golden images. We're going to be able to bring golden images and attach them to the cluster automatically. That is a huge step forward for immutable infrastructure. So let's run through this real quickly. AMI. All right, the next step is the definition, that YAML file of the cluster definition. And here you see I'm defining infrastructure pieces, like my secrets and my creds. I'm defining what sort of instance type. I'm defining machine sets, what version of Kubernetes, the kubelet I want, what version of the Docker I want. This is all baked into the YAML versioning. So I can come into here and I can change it anytime I want. I can then execute an install procedure. It automatically runs through it, feeds that YAML file to that CRD, to that administration controller, and you notice on this side of the screen, the cluster is starting to install itself. So this is a significant speed improvement than what we have today because we're using golden images. We're bringing up pre-baked concepts. Now I'm doing a get clusters, and how do I do the get clusters? I have that ability to feed this to the cluster registry project, which is another project that is coming probably the middle of this year in just September timeframe. It's an API where I can ask it how many clusters I have, what are their names, what are their namespaces. As we deploy in this manner, we're feeding information into that cluster registry, so you have that ability. Notice here there's also a status. How many of you install your clusters and you have no idea if they finished or if they're healthy? We now have an API object that says healthy, that says I'm installed, that says I'm done. So that's another huge improvement in what we were able to do in the past. And then lastly, this is probably the coolest part. I can go into that YAML file and I can change how many nodes, I can change what version I'm running, I can change a lot of the configuration to a different variable, and I hit save, and bam, just like it was a pod on Kubernetes, that cluster changes for me. So this is a huge improvement for those of you out there in the world who own multiple clusters. And with that, I'll hand it over to Mark.
Thanks, Mike. All right, so one of those other things you need to consider on day zero is what you're going to do for networking. So what's the networking infrastructure going to be? So what I'm going to talk about here is OVN, which is going to represent our next-gen default OpenShift SDN. So there's a number of reasons why we chose this, which I'll get to in a moment, but I'm just curious, by a show of hands, we don't have any kind of call home software or anything like that, so I don't have any other way of getting this data. But who in here is using the default OpenShift SDN and has not plugged in a third party? Okay, good, thank you. We of course do provide a pretty rich, we integrate with a pretty rich ecosystem of third party vendor SDNs for those customers that do find those useful for their particular use cases. But what we're targeting here is the 80% use case that's going to work for the best for the most people right out of the box as the default. So OVN, some of the reasons why we, this is not an exhaustive list, but some of the reasons why we chose it as the future is, one of the most important things is developer community. So in addition to having more individual contributors from the community, more vendors, we also see this as a portfolio consolidation across some of our largest platforms. So in addition to OpenShift, OpenStack, and Rev, they either have already gone to OVN as their default SDN or they're going to it. So we see this as a platform efficiency across the different ones. So another big reason, of course, is the acceleration of some of our most important features. So we have a roadmap with pretty critical features coming in from customers. And an OVN actually represents an acceleration to that, not only from a programmatic point of view, it actually simply makes things easier to develop. So say, for example, we're going to be moving eventually from an egress IP per namespace or per project to an egress IP per pod so that people can filter it at the edge. To do that in OVN is far easier than it is to do it in our existing SDN. And actually, I'm not going to go through each one of these, but actually some of these we kind of quote unquote get for free. Like, for example, IPv6. The OVN already is end-to-end IPv6 capable, so when you know Kubernetes is, then we're good to go. So we see this as a faster way to the development of our features. Speaking of network plugins, one of the other things that I work on is I work with the OpenStack side of things and the team of engineers over there to, with the sole goal of improving the default out-of-the-box experience for OpenShift on top of OpenStack. So the way this ultimately works is there is a project called Courier at the OpenStack level. Some of you may be familiar with it. What we did was we developed a CNI Kubernetes plugin called Courier Kubernetes. When that's plugged into Kubernetes at the CNI point, you can think of it as providing an adapter or a connector. It provides the necessary plumbing that you need to communicate directly to the underlying OpenStack layer, and more specifically, Neutron. And so what does that give us? Why did we spend so much energy to do that? Well, one of the big things that we've heard from our customers is they want us to remove that double encapsulation. Currently, we've got an OpenShift SDN on top of an OpenStack SDN. So you have double encapsulation of packets. So if we instead provide the plumbing to connect to Neutron directly, then we essentially collapse that down to a single SDN. Side benefits to that are things like once we have that plumbing established, then we can do things like load balancing as a service, firewall as a service, DNS as a service, using these rich services that are being provided already by the underlying OpenStack cloud. Other things as well is anything that's already been certified with, say, Neutron, well, we get to use that in OpenShift now. And then also any tenant isolation that's being enabled in the underlying layer, that becomes directly effective to provide isolation at the OpenShift layer as well. And finally, we can bring bare metal provisioning and management to OpenShift by taking advantage of basically direct plumbing access to the underlying Ironic project. So lots of good things there. There's other enablements for improving this. This is one very important one coming soon. The next thing I want to talk a little bit about is Istio. So Istio is a sidecar implementation of some of the features and functionality that's required for enabling and creating microservices and providing for them the kind of rich networking and control that they require to formulate and be chained together and formulate applications and speak to the outside world and so on. So what Istio basically does is rather than the developer having to be concerned with all of that programmatic networking and connectivity and building their own circuit breakers, et cetera, inside the mesh, what Istio does instead is it says, let me just implement a sidecar container whenever you implement one of your services within that same pod. And then let my sidecar container, you can enable and configure all of the items that are in there pre-built, ready to go for you, and it just simply, you can use it. Great thing about that, you don't have to change any of your code. It doesn't care what language you're using, it just simply provides this generic functionality. They ultimately formulate this mesh so that they all talk efficiently between each other. That mesh is managed and controlled at the control plane by a few Istio projects like Istio Pilot, Mixer, Auth, uses Jaeger for the tracing and so forth. But these things work together to provide not only access control, they provide metrics collection and distribution to things like Prometheus. They provide configuration management, traffic analysis, on and on and on, many different things at a higher level. But ultimately what we're trying to get to is we're trying to get to that point where this service mesh is providing, there's a short list on the left-hand side there. It's providing some of the advanced networking and control mechanisms that's required for these services to be glued together, stitched together to formulate applications. So that being said, let me move on to, without ruining this laptop here, move on to a demo. Steve, where did you put the demos in there?
Can't get a Fedora guy to use the Mac.
Don't start it quite yet. All right, thank you. So before I hit play on this recording, I'm going to tell you a little bit of what I'm showing you. So first of all, one of the things that's going to be the primary interface to Istio is going to be this observability console. This is the UI. It's called Kiali. Kiali got its name from the Greek word of monocular. And so what this provides is the primary interface to the service mesh construct and all other things inside of it. It is, I would normally show you something else as the splash screen. There is a dashboard that's a work in progress right now. It was not ready at the time of creating this short video here, but expect that to be added in the future. So I'm going to go ahead and start this up. So what this first thing is showing is essentially this would be an example of an application built up from a number of services. The services would be the round circles. You can see that one of those, several of those are encapsulated with a rectangle. That represents a single service with several versions. I can see connectivity between them. I can see if it's a healthy connection with the green and so forth. If I want to, I can see all my services from a pull-down menu that shows me the different services, and I can slide between them. One of those things about this that's also work in progress is, let me pause it here for a moment. One of those other things that's also work in progress is currently Kiali only looks at, it looks within namespaces. It doesn't have the ability to show the service across namespaces, but that's coming soon. So these are some different applications just as representative examples. Going back to the primary one here, you see that if you were to select, for example, one of these particular trace elements, not only does the green color as opposed to red or dashed show you that it's a healthy connection and the direction of the traffic, the fact that the connection was established between those two things, but I can get more details about it on the right-hand side. So I can get information like number of requests, if there were errors. I can change the duration. The default is to show 1 minute of span, but you can kick that up 10 minutes, 30 minutes, whatever. Also, what you can do is you can increase the polling interval on that as well. This is just showing how it shows more of a larger history of what happened on that particular trace. If you click out into the white space, it actually shows you it for the entire service as a whole. Next thing it's going to show, I believe, is if you don't like this particular layout, maybe you got a really complicated service mesh and need to rearrange things a little differently. There are alternative layouts, and you can define your own. There's also, if you click on the namespace that's on the right-hand side that app was part of, it also presents a list view. From this list view, you can get health information, you can get error rate information, but usually what you would probably do, rather than, if you want something a little more information, you can drill down into the details of each one of these namespaces and get information about the services, a slightly different look to it. Down at the bottom, there's a series of menus that will give you information about, for example, your routing rules, your deployment configs, information about your endpoints and the ports and protocols to which it connects to. Again, the health check information is in there as well. Let's try and speed this up a little bit. I don't think that did it. Not the forward arrow? No. All right. That would be too obvious. So another drill down that you can do as well, too, from that menu is you can go down into the metrics. And so for each one of those connections, you can see both ingress and egress on the service as a whole, which is what this is viewing. Lots of views, total requests per second, the duration of each request. You can get a lot of different information about that, response times, response sizes, et cetera. You can change the duration of the view. You can change the polling interval. And very quickly here, this is going to change to another view, which is showing us that if you did enable Jaeger, you can and configure it, then you can also get tracing information. And finally, the last thing here is this is also a work in progress, which is we are pulling the Jaeger user interface into this Kiali user interface. So in this particular case, this is about as far as the team has gotten, but again, a work in progress. Looks good. It's going to look great, I'm telling you right now. So that's what we've got. So that's all I have.
Cool. Thanks, Mark.
Sure.
So, you know, why did we show you what we showed you? And apologies for the videos, but this is fresh off the press. A lot of this stuff isn't shipping until the first quarter of next year. So I'm going to very quickly talk about some of the other stuff, right? There's a lot going on in Device Manager for those of you who have GPUs. Preemption, a new quality of service class, descheduling, rebalancing the scheduler. All those come around the 3.11 timeframe from like September to December. So that's a big one. Federation version 2 is back on track. I know there's fans out there that have been watching the SIG. So that's going to take into the proposal stage until the end of this year, and then maybe this time next year we'll have real GA quality multi-cluster federation on how you deploy your services. We talked about a lot of the day 2 stuff. Other stuff in day 1, we have serverless. If you saw those sessions, OpenWhisk on the platform, it's now in dev preview. You saw a keynote on deploying virtual machines on OpenShift using container native storage. That's the KubeVirt project. Pipeline's getting better. Anybody go to the Windows container session and see Windows containers deployed on OpenShift? That was pretty mind-blowing. And then the Quay registry. Who's interested in that Quay registry? Yeah. So, you know, we can integrate that better with OpenShift. We're not going to remove it from its goal in life, which is to be a generic Docker registry, even if you're not using OpenShift. So that's safe land for you. But we can accelerate the awareness with the OpenShift platform. And then lastly, this looks like our timeline. These will change over time. There's a lot of features in each one of these buckets. But our next release is 3.10. It comes in around the 11th of July. Wow, that's a lot of pictures going on right now.
I got it.
Okay, just so we know. The next one's going to be September. Now, that converged platform with all the CoreOS technologies, we're aiming for that December timeframe. Now, here at Red Hat, we enjoy our holidays, and we shut down at the end of the year, and we wake up in January. So if I don't finish before that shutdown, then that'll bleed into January. But that converged platform looks like it's on track right now, and you will be able to enjoy that around the holidays. After that, it's March. And March, if you notice, is really that Istio release. That GA quality Istio release is probably the biggest thing coming out in there. And then serverless gets even more and more formed. So there's a lot going on in the platform. I hope you enjoy using it, and thank you for using it. This has been the best year we've ever had. It's just mind-blowing how many customers are coming forward and telling their stories. And thank you very much for that.